Hello everyone, in this video we are going to solve the problem number 1.41 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A point moves in the plane so that its tangential acceleration Wt is equal to a and its normal acceleration Wn is equal to bt to the power 4, where a and b are positive constants and t is the time. So let us say the point is moving in the xy plane. This is x direction and this is y direction, and let us say the point is moving in this particular curvilinear path. Okay, so this is the curvilinear path in which the point is moving, and at any particular time instant we are having the tangential acceleration that is denoted by Wt and the normal acceleration that is towards the center of the curvature that is forming at this particular point. So let us say this is the curvature it is forming at this particular point, and this is the radius of curvature. Okay, and this is the normal acceleration towards the center of this curvature, and the value of this particular component of acceleration, let us say this is Wn, and the expression of Wt is given as a and the expression of Wn is bt to the power 4, where a and b both are constants. Okay, and it is saying that at the moment t is equal to 0 the point was at rest. That means at t is equal to 0 velocity is equal to 0. Okay, and in the problem it is asking to find the curvature of the point's trajectory and the total acceleration w depend on the distance covered s. Okay, so we can write Wt is equal to a. The tangential component of acceleration we can write it as dv upon dt, because velocity is always in the tangential direction. That we can equate it to a. So let us take dt to this particular side, then we will get dv is equal to a times dt from t is equal to 0 to t, and at the time instant of 0 we are having 0 velocity, because at the time instant of t is equal to 0 the point is at rest, and at the time instant of t the velocity, let us say v. So if we integrate 1 then we will get v from v is equal to 0 to v, and a times t from t is equal to 0 to t. So from here we will get v is equal to a times t. So this is the expression of velocity we got in terms of time. Now in the problem it is asking to find the curvature in terms of distance covered s. So we have to find the velocity also in terms of distance. So for that we can write at is equal to v dv upon ds, that is equal to a. Let us take ds to this particular side, then we will get v dv is equal to a times ds. Integrate both the sides from s is equal to 0 to s and v is equal to 0 to v. Integration of v is v square by 2 from v is equal to 0 to v is equal to a times s from s is equal to 0 to s. So here we will get v square by 2 is equal to a times s. So we will get the expression of v square as 2as. Okay, so this is the expression of v square we got in terms of distance. Now there are two different methodology to find the radius of curvature that we have seen in the previous videos as well. Let us say first methodology is by using the formula, that is r is equal to 1 plus dy by dx whole square to the power 3 by 2 whole divided by d square y divided by dx square. But in order to apply this particular formula we have to find out y as a function of x. Okay, so we will use other methodology. That means, for example, let us say if the point is moving in the circular path, okay, and at that particular point let us say the force is acting towards the center and let us denote it as f perpendicular, and velocity is in the tangential direction. Okay, so we can write f perpendicular is equal to mv square by r, where r is the radius of curvature. Similarly, here in this curvilinear path, it is forming the curvature at each time instant. Okay, different radius of curvature at each time instant. So for that particular point, we can equate the centripetal force, that is, let us say f perpendicular, we can equate it to mv square by r, and from here we can find the radius of curvature. Okay, so let us first write f perpendicular. F perpendicular is equal to m times centripetal acceleration, or the normal acceleration, which is represented by wn, m times wn, that is equal to m into, and wn is given as bt to the power 4. So we can write here m times bt to the power 4, and that we will equate it to mv square by r. Okay, so from here we will get m times bt to the power 4 is equal to m by r into what is the velocity that we have found out as at. Okay, so we can write a square into t square. So here will get cancelled, and we can find r is equal to a square divided by bt square. Okay, so this is the radius of curvature we got in terms of time, but we have to find out in terms of distance. So for that we can equate these two things, and we will find the relation between time and distance. Okay, so we can write at is equal to 2as, at whole square is equal to 2as, so a square t square is equal to 2as, and from here we can find the t square is equal to 2s by a. Okay, let us substitute the value of t square, and we will get here r is equal to a square by b into, and t square is equal to 2s by a, so that means a upon 2s. So from here we can write the radius of curvature is equal to a cube divided by 2bs. So this is the expression of radius of curvature we got in terms of distance. Now come to the second part of the problem, in which it is asking to find the total acceleration depend on the distance covered as. We know that at any particular time instant, the tangential acceleration is always perpendicular to the normal acceleration. So the total acceleration, let us denote it by w total, is equal to wn whole square plus wt whole square under root. What is the value of wn? That is bt to the power 4. So b t to the power 4 whole square plus what is the value of wt? That is a. So a square under root. So from here we can write a square plus b square t to the power 8 under root, and from here we can find the value of t to the power 8, that is t to the power 8 is equal to t square to the power 4, that is equal to 2s by a to the power 4. So let us substitute the value of t to the power 8, and we will get here a square plus b square into 2s by a to the power 4. 2s by a to the power 4. Okay, let us take the common, that is a square. So we will get a times 1 plus b square into 2s to the power 4 divided by a to the power 6. So from here we will get a times 1 plus 2 into b into 4 into b into s square divided by a cube whole square under root. So this is the expression of the total acceleration we got. So this is the expression of the total acceleration, and this is the radius of curvature at any particular distance. I hope the entire procedure is clear. Thank you.